So welcome everyone to the tutorial for the NPTEL course Programming Data Structures and Algorithms in Python. It's offered by Professor Madhavan Mukund, as you already know. So it is a week two tutorial. So week one, you all must have got the video and you know the presentation, and you also might have able to ask for the access for the notebook that I was using last time. So it will be same this time as well. You will be shared with the presentation, you'll be shared with the video, and you can ask for the access of the notebook that I'm using. So basically, we'll as this tutorial, so we'll be trying to solve some problems here. We'll try to know, we'll try to see how can we approach towards the problems. So you all must be aware about the average, arithmetic average of of your numbers if they are given to you. So let us say you are given with a number 1, 2, 3, and you are asked to calculate the arithmetic average. You can simply add them all and divided by the total number of elements. So like in this case the elements are 3, 1, 2, 3. So 1 plus 2 plus 3 6 divided by 3 divided by 3, which is the length of the, if they are listed in a list 1 2 3. So it's like a length of the list, so you can divide by that and you'll get 2 as the arithmetic mean. So but here we'll not be calculating the arithmetic mean, we'll try to calculate the weighted average. So first of all, we would like to know what is the weighted average. So in case of weighted average, so let us say our problem is calculate the weighted average of elements in a list. So in a way, you will be provided a list. So with that, I mean, in that list you'll be, of course, you'll be provided some numbers. So you need to calculate the weighted average of all those elements in the list. So first of all, what is weighted average? So let us say you have a list that has four numbers, maybe 1 2 3 4, and I just want to say that some of the numbers are more important than others. So let us say I want to say that 4 is more important, and the effect of 4 should appear more prominently in average. So so we would like to there, the arithmetic average will not be very very meaningful in that case. So then we would look for the weighted average, so that we would give more weight to 4 and lesser weight to other three numbers. So when we do the averaging after that kind of weighting, we will get the average, which will be different than the arithmetic average, and it will be biased towards the value 4. So the definition, as it says, it is an arithmetic average calculated for a set of number considering their relative importance. So as I said, that if we want to give the importance to a particular numbers, or to a set of numbers, and less important to others, then we will weight them according to their importance, and then we will be averaging to calculate the weighted average. So now what are the weights basically? So weights basically define the relative importance of the numbers. If we are talking about a list of numbers, so basically weights specify the relative importance of some numbers with respect to others. So let us say that if we have list of n numbers, so those n numbers need not be in a sequence. They can be anything. They can be positive numbers, negative numbers, they can be real numbers. So any type of numbers they can be. So they, if they are in a list, and we define the weights that are equal in number with the with the number of elements in the list. So according to the importance of the element in the list, we will provide them some weight. this weighting is not random every time, but just for the purpose of learning, we'll be discussing an example where we'll be choosing a weight on a particular basis, but there can be various basis uh, for the definition of weights in the weighted average. So now let us say there are n elements in the list. So in I mean so similarly there will be n number of weights corresponding to each element. So I'm calling them omega 1, omega 2, and so on. Now if now the weights should be uh, they should be normalized. If they're not normalized, then we will not get a realistic average, even the realistic weighted average. We'll see why. So, but for now, if the weights are normalized, then what is the meaning of they are not normalized? So, if the summation of all the weights is not equal to 1, then we'll say the weights are not normalized. Then we'll use a formula to normalize the weights. So, so normalized weights. So, let us say I am choosing the ith weight in this case. So, normalized ith weight, I'm calling it omega norm I, will be equal to omega I divided by summation of all the weights. So I'm doing nothing. If you see in our equation 1, if we divide both sides, you know, just wait. So in our equation 1, if we divide, okay, hold on. Uh, okay,
Will you
so
share your screen, please?
uh, are you not able to see the screen?
Yes,
No,
sir.
No, sir.
No, sir.
So
No, sir.
anyone
Screen is not visible.
anyone is not able to see the screen?
Sir,
No,
no.
sir.
No,
From
sir, it's not
starting.
sudden.
We are just
Okay, okay, okay. So yeah, wait, I will be sharing the screen. Are you able to see the screen now?
Yes, sir.
Yeah.
it
Yes,
is
sir.
for now, yes.
Okay, okay,
Yes, sir.
okay. So I'll kind of restart because you must not have understood what's going on. So basically, by the definition, as we have discussed, it's a arithmetic average that it's arithmetic average that is calculated for set of numbers considering their relative importance. And by relative importance we have discussed that if we feel that our average should be biased towards a particular number or towards a set of numbers as compared to others, then we will give them the weights according to their importance. If the importance is more, weight will be more. If the importance is less, weight will be less. So next thing we discussed, if the weights are not normalized, then we should be normalizing the weight. Uh, because if we won't normalize the weight, even the weighted average will not be realistic. So because you will be multiplying with some numbers out of the blue, so it will not be a realistic kind of average. So it's necessary that doing the weighted average we must normalize all our weights. So what is the meaning of not normalized non-normalized or normalized weights? So if the summation of all the weights is not equal to 1, so if the summation is not equal to 1 means weights are not normalized. But if you look into the equation 1, if we divide left hand side, that is summation of omega I, on both the sides, so we'll get 1 is equal to omega 1 divided by summation of omega I, omega 2 divided by summation of omega I. Similarly, omega I divided by summation of omega I plus omega and omega n divided by summation of omega n. So in a way we can say that our normalized so in a way we can say that the summation of all the weights in this case will be equal to 1. So if we divide on both sides by sigma omega I, the summation of weights will be equal to 1. So now we can say that after doing the after dividing both sides by sigma omega I, we can say all the weights are normalized. So Then following that, the formula for the normalized weight is, so if I want to check if the ith weight is normalized or not, so omega normalized ith will be equal to omega I divided by sigma summation, summation of omega I. So after normalizing the weights, we will be calculating weighted average as, uh, as we have discussed, the weights are responsible to give the relative importance to different numbers that are participating in the average. So we will be multiplying with the number. We'll be multiplying the element with corresponding weight. So weighted average will be equal to omega norm 1 multiplied by element 1, that is we are saying it is a1, plus omega norm 2 multiplied by a2, and so on, and we will divide it by n. So that is a simple definition. So we sum all the numbers and divide by length of the, we divided by the the length of, the numbers, if we put them in a list. So here, as we have discussed, a1, a2, an are the elements in the list, and omega norm 1, omega norm 2, and up to omega norm 1 are the normalized weights. We must remember that as we are doing weighted average, so we should provide weight to all the numbers. Okay, so that we must take care about. So following all those formulas and relation, we will try to see that how can we, how can we program this thing or automate this thing using Python. So from here
Can you
I will be
explain
following.
what is weightage exactly? What do you mean by weight here?
Yeah, weight is basically okay. So I would suggest you guys, please keep your questions for the end. First, stick to the definition. Weight is simply responsible for the relative importance of the number that is participating in the average. So, for example, I would say, let us say, uh, um, uh, let us say I want to see that what is the average what is the average value of maybe the biscuit, Parle-G biscuit packet over the years. So if I want to say that, okay, let's check from right from 1900 to up to now, what is the average price of the Parle-G biscuit. So we must be very careful while saying that in 1900 the value of rupee was this much. We can say in 1900. Let us say for the time being, there is a currency. I will be calling it currency only. So let us say in 1900 the value, the 100-gram Parle-G you used to buy for maybe x units of the currency, and now you are buying it for the y units of the currency. So you cannot simply average them and tell that, okay, this is the average value of Parle-G over those many years. So because there are many factors they're responsible for the change in value of the currency. So recent value of the currency, it should get more weightage in the calculation rather than the earlier value of the currency. And there are many more examples where weighted average become more meaningful than the arithmetic averages. Okay, so please keep your questions for the end. Okay, so so this is our problem. So first what we would do, we would write a function that normalizes all the weights that we are going to supply. Okay, so and how we are going to normalize that we have already seen. Fine. So we should the summation of weights, if not equal to 1, then we will divide them all the weights by summation of 1 to get the to get the to get the weights which has summation equal to 1. So here we have defined this function. You can see this function here. This is norm of weights, so we'll supply it supply it it will supply it a data type that is in this case it's a sequence. It is going to be a list because we are going to average all the elements in a given list. So correspondingly we'll choosing weights also in a list that has same length. So now, for now, we will say that weights will initialize the summation of weights by saying summation of weights is equal to 0. Now, we'll say that, okay, for I in the range, length of weights, if type of weights is not int or type of weights is not float, if it's neither int nor floats, in that case we should return that please provide a correct data type. So so if our data type is correct, then we will simply say, okay, sum of weights, which earlier was 0, then in first iteration it will be equal to sum of weights plus weights first element of the list weight. And then we will keep on running it up to from first element to last element. So this is how we'll get the summation of weights, and then we will return the length of the weight, that is I sorry the the I mean the corresponding element, that is I, divided by weighted sum, that is the sum of weights for I in weight. So this method is basically it is basically called the so basically in this method what we are trying to do is we are trying to create a list that is that contains the elements. So the element are coming from I. So sorry, the elements are coming from weights, and first element we are, and corresponding element we are replacing it by dividing it by weights of the sum of weights. So this is how we'll normalize the weights, and then we will calculate a function. Then we will define a function that calculates the uh, weighted average. So for that we have defined a function. It takes but this function takes the two inputs. It takes the list and it takes the weight list. So then, if our weight that we are supplying are not normalized, so that is possible. Like, if somebody supplies the weight, he does not put in much thought to it, and it supplies weights that are not normalized. So what our job is, we have already defined this function. With the help of this function, we normalize the weights. Then we will check a very important it's an important line that you all must focus this line. So we will make an assertion. We will say that length of weights should be equal to length of list. Okay, so if length of weight is not equal to length of list, it should return, okay, it should return an error and it should stop right away. But if it passes this assertion, if length of weight, we are careful enough to supply the length of list equal to length of weights, then we will initialize weighted sum. So this summation will be weighted, so we will be multiplying each element with corresponding weight before making a summation. Okay, then for every element we'll check whether it's just if you want to be very careful, then you can check. Even if you don't check and your user is he's aware that the data type that you can accept in your list is only integer and float, that is also fine. But if you want to make sure from your side that user must user must provide a proper input, in that case you can you can put in a condition that if the element in the list is not an integer or element in the list is not a float, you please return that input is not correct and kindly provide a proper input. But if the input is correct, then weighted sum that we have initialized to be 0, it will be equal to weighted sum plus the first element in the list or the ith element in the list multiplied by ith weight in the wait list. So, or the normalized wait list basically, because we have normalized our weights. You can see here we have normalized our weight by using the norm weight function that we have decided above it. We have defined above it. So uh, so this is how we will calculate the weighted sum, and then we will, return the weighted sum divided by length of the list. So it is like we are using the formula in, in equation 3. So with the help of this formula, we calculate the weighted average. Similarly, for unweighted average, we do not require, for comparison, just we'll see that how weighted average can be different from the unweighted average. So, in case of, unweighted average, we only want input of the, input for the elements, and we don't want input for the weights, because we are not going to provide any weights for calculating the average. So here also we initialize the unweighted sum, then we check whether the input provided is correct or not. So you can escape if you want. Then we simply run the loop to calculate the sum of all the elements in the list. So basically, this is the loop to calculate the sorry. This is the loop to calculate the sum of all the elements in the list, and then we will return the unweighted sum divided by length of the list. So here the only difference is we are not providing any weights. We are saying, okay, all the elements are equally important, and we don't want to be biased towards any element for the calculation of our average. So we will see how different they can come. So list will sorry, this file will take some time, to start. So yeah, so it's ready now. Okay, so we will check that, for list one, our inputs were, these inputs, where I had also provided a complex number in between, but we have already said that it should not be any data type other than integer and float, so that is why it has returned us an error. Similarly, for type 2 list 2 also, if we check, it will again give us the warning, and it will terminate the function. So okay, so this is 3 actually. Call it 3, and then we will see how will the 3 perform. So I will tell you how I have chosen these weights, but this is not a standard practice. There can be, in real world, in physical world, there can be ways to there can be logical explanations for these weights. So here, if we can see that the weighted average is somewhere 4.79 and unweighted average is 28.47. So basically, here if we see, in case of list 3, if in case of list 3 and wait list, if we see, we are providing most weight to 83, then second largest weight to minus 99, then third largest weight to 32, and so on. So uh, negative numbers are also getting larger weights, so because of that, this average is, getting biased towards those negative weights and negative elements, and that is why we are getting a lesser average as opposed to unweighted average. Okay, so here what I have done, I have chosen average, I have chosen these weights just, in the, in the increasing direction of the index of the list. So if for 0th index I have given one weight, for the first index I have given weight 2, second 3, third 4, and so on. But there can be, there can be some logical explanations when you are solving the real life problems for the choice of the weights. So okay, so basically this Okay, so here what we have done is we have provided a list, but we have provided a list on our own. But sometimes we may require that the list is we are the developers. We have developed some code, and we want user to use it. Okay, so most of the time what happens is the people in software community, they produce the codes or they produce the utilities, and other other users, they utilize them for their own purposes. So for example, in your mobiles, you have the calculator utility. It has been developed by developers, but now as per your choice, you provide an input to your calculator and you get the output. So here what we will do is we will see that how can we give input as a list, as a list of number. So before that, we just want to see why I'm even discussing this. So let us say I'm saying that a is equal to input. Okay, and in this case I will be inputting an integer. Okay, so let us say I'm going to input an integer. I said maybe 2, then I press enter. So 2 is already input. So we will check the type of A. Type of A is coming out to be a string. We provided an integer, you have already seen, but we are getting an output as a string. So we need to be very careful when we are providing the inputs to I mean, we are providing input. If whatever input we provide, that input will be converted into a string. So we must be careful while processing those kind of things. So as I want to input an integer, so what would I do? I will say that a is equal to int. So int is a class. What int would do, whatever you would provide it, if it can be converted to an integer, it will be converted to an integer. Okay, so we will see how it works. So let us say now I provide it to, like last time, and it is stored. I check the type of a, and it is integer, as it was intended. But if we make some input that is not that that cannot be converted to an integer, in that case, it has shown us an error that it cannot be converted to an integer with base 10. Okay, so we need to be very careful while processing those things. So similarly, if I want to input a list of numbers, so in our case we want input to be a float or an integer. So now this is the process that we are going to do to get a list of list of numbers, rather than a list that contains so many I mean that is actually an uh, uh, that is a string. I mean, we wanted the list of numbers, but we are getting a string. So we need to be careful about that. And if you want, you can check the thing, check that following the similar, following the similar method. You can simply ask for an input, and then you just input, then you simply input list here. Maybe you can call it 1 4 7 3, and I am also providing spaces. The string actually calculates the space as one string literal. Okay, so we need to be careful about that. So when we press enter, it is not going, oh sorry, it is not going to, it is again going to produce an error. But in case I am going to remove an integer, and if I run it now and provide a list that is 158 and put enter, we'll see what type of list we are going to get. Okay, so if we press enter, we are getting a string. So everything inside it a string, inside it is a string. So if I try to check the zeroth element, the zeroth element is basically um, it's a rectangular bracket. So it's a opening of rectangular bracket. So that is not intended when you are supplying a string. Sorry, when you're supplying a list. So for that we'll follow this method. We will ask user for the input. So but user must be careful that he must enter elements that are separated by comma. We can also ask for input that is not separated by comma or separated by spaces, but then our instructions will change a bit. So for list we will ask for the input, and for weights also we'll ask for the input. And then we will what we'll do, we will split the input list, whatever has been input. So we have got it into a string form. So whatever is input, we will use a function. It's an inbuilt function in Python, so you can try and use it how it works. So what we'll do is whatever has been input, we'll just split it by comma. So that is why I asked here, that is why I asked that the list should be separated by commas. Okay, so the way we had given here, so we have given a number and then comma, then number, then comma, and so on. So now if our list is input by a comma, and then we'll split the list. So and then we'll again split the weight list. Then we convert all the elements that we have splitted and stored in a list. We will convert all the elements to float. Okay, so either we convert it to if we convert all the elements to integer, then what would happen? If you have supplied a number maybe 28.3, it will be converted to 28. So we need to be careful. But if you have supplied a number 5, it will be 5.0, which is as good as 5. So it's better that we convert it to integer. And then similarly we'll do for weights. So if we do it that way, so what would happen? All the members in the list will be, as LST and weights are the lists. So as we already know that the lists are, they can be changed. There are some sequences that cannot be changed, like if we talk about tuple or strings that cannot be changed. If you want to change a string, you'll have to store it in a new variable. But in case of list, we can mutate the list without creating another list. So what we are doing is, we have a list here, and what we did is we changed the each element of the list by float of that element. So this is how we get the float values. But here we need to be careful that whatever values we supply in the list, they must be either integer or float. So we'll try to run this, and we will supply the list 3, the same values we are going to supply.
I have one concern. Can I ask it now regarding this thing only?
If you keep it for later, it would be better if it is not too urgent, because
Okay.
the continuity will be lost.
Okay. Okay.
Yeah. So if it is very very urgent, then only you guys should say anything. Okay. So next is we are going to just copy this, and we are going to provide the weights. Oh, actually, we should not have provided this braces, because we have seen that uh, you even this rectangular bracket, they are also converted to string. So we need to be careful. I made this mistake here. So So for list, we are providing list by separating it by commas, and then we will supply weight. So as I remember, it was 1, 2, 3, 4, 5, 6. So it has calculated the. Uh, okay, so we have supplied. Now we will see that the list or weights that has been created, for which if we run, we are going to get the same output as we got earlier. So basically we need to be, I mean, if we want to automate the whole process and we don't want to supply the list every time, we don't want to trouble the user every time to go to to go to the instructions and then change there, then it's better to automate it better. Then for that we will be using an input function, but with input we have to be careful. Okay, so for the same reasons that we have seen. So now our next problem will be checking if a reverse of the string is same as the string. So I'm calling it problem 2a because it is connected to the coming problem. So for that we'll be following a standard procedure. First of all, we'll be checking whether the input is a string or not, and if it is a string, then we will proceed further to check whether the reverse of the string is same as the string or not. Okay. So for that, basically, such data types which, when are reversed, such numbers or such strings, they are basically called palindrome. So I'm calling this function as check reverse. So uh, as you can see, this is a very simple, this is a very simple instructions, easy to understand as well. So we'll check whether what you have supplied is a string or not. If it is not a string, then we will raise a warning and we will terminate the program. But if it is a string, so if it is a correct input, then what we'll do, we'll say, okay, return a condition string equal to string colon minus 1. So what is this colon minus 1? So basically this colon minus 1 is nothing but you must have seen the indexing methods for lists. So basically here it simply says that string start, then colon, stop, then colon, then step. Okay, so this is the standard syntax for indexing. Okay, or if we want to split a particular sequence inside the sequence, and this is the standard way to do that. So basically, if I don't want to specify the start or stop, then what we would do, we will omit this start, omit this stop, and but we need to be careful while we are giving the step. If we provide the step to be positive, then start will be from the start of the list, and if our step is negative, the start will be from the end of the list. So if our step is negative, let us say our step is minus 1, so our list will start from n. Let us say n is the last number, and it will go beyond 0. So but if we put 0 here, then what it would do, it would run one value greater than 0. Okay, so for that, if we want it up to 0 or the 0th index, we will simply omit 0. So if we omit n as well, because it's redundant whether you put n or not, if you have given step minus 1, it will anyways start with end of the index. So let us say you have a list which has indexes 0, 1, 2, 3. So it has 4 elements with indexes 0, 1, 2, 3. So if we say that string colon minus 1, so it will start with 3, then will go to 2, then will go to 1, and then will go to 0. So basically here what we are trying to do, whatever string you have provided, you are reverting it. because you are now supplying the values to to the string as last index, then index before the last one, and so on up to the first index. So if we do this, we'll see if it works for let us say we have this a word Malayalam, which we already know you can read from start or you can read from the end. It will be same. So we can check that it returns true. So we can use another word, maybe let us say we use a word car. We try to run it. It says false because you cannot read car backwards and get the same string. Okay. So
What if we give, instead of -1, we give -2 or -3 a step?
yeah, if you give -2, then it will skip one step. So it
Okay,
will be like n, then n -2, then n -4, and so on.
okay.
Okay, so you guys should try those things after getting out of these tutorials. So whatever functions we are trying to see, you should go back and try to learn, try to experiment with them. So it would be really helpful. Okay.
Thank you.
Yeah.
Sir, excuse me, sir. In the first return statement, it is a string, and in the second statement, it is a
Yeah.
means true or false. So a same function can return two types of variables. That means one is in string and the other is a boolean.
What you're
So I
saying?
am
What you're saying? Can you say
sir.
again?
Sir, in the check rev function,
Uh-huh.
in the first return statement, it is a means string,
So we are
and
what
in
we are
the
doing
means
is we are
enter a valid input, and in the second one it is a boolean. So same, the function can return at a time a string, and
please
another time it can be a boolean.
please be very clear. You are talking about line 2. So you have four lines. We talk about you're talking about line 2 or line 4.
It's talking about line 3 and 4.
You are talking about line 3 and 4.
Yes.
Three and four.
What he's saying
Okay.
is it can return either a string or a boolean. And
No. It is a boolean. So it will return either true or false. So you can see it's returning either true or false.
no,
It's
but
not
if
returning the string.
no, but if the if condition is true, right?
Yeah.
There's a return. That is a string. You are returning a string this time.
No. You guys are missing the point. It's not, it's not equal to. It is double equal to. Means it's a condition. So it will return the condition whether it's true or false. So that is why it's
You
returning whether it's
know
true or false.
the string that is enter a valid input, you're returning that also. Under that
Where?
certain,
Where?
at line 3, you are returning
No,
return
no,
enter
no.
the
It's
input.
it is just saying that if the type of a string is not a string, if the
Yes,
type of your input is not a string, then you should. So let us say I am going to call this function and I am going to give two, a integer. So it would say that okay, please give me the valid input.
yeah,
Are you
that
getting
is
the
what
point?
he's asking. Means it can return any kind
Okay,
of
is
a
it clear now? Because we are short of time. Is it clear now?
Yes, sir.
Okay, so let's move on, and we will address the question at the end. Okay, so next problem that is related to this one only. What we want to do is we want to reverse words in the string. So let us say a string is given to you. So for example, I have chosen a string that we have tutorial for our course every Friday. Okay, so I have chosen this string as an input string. So there can be various ways we can get the reversed string. So one can be like Friday every course hour for tutorial have we. So what we have done is we have we have reversed the sentence. But in next case, what we could do is we could reverse only the words, but the position of the words remains same. So it is like for V it's EW, for have it's EVAH, and so on. Okay. And other thing we could do is we could reverse the we could reverse the words, and also we could reverse the sentence. Okay, so these three things we will try to do here. So that is why, because it is also a problem in which we are checking the reversals. So that is why I'm calling it problem 2b. So first, we'll be defining basically three methods to mimic these three reversals. Okay, so 1, 2, 3, these three reversals. We'll try to look at the three methods, or we can maybe discuss one or two methods. You go home, you try the third method. Okay, so let us say what we want to do is we want to, if our string, given string is this, we want our output to look like this. Okay. Okay. So what we would do, we would define a function that takes input as a string. Okay. Then it's the same line that we have seen above. If the input is not a string, it will produce a warning. Then what we would do, we would do a split function. What it does is it splits all the elements of the list that are separated by a space. So when I say split and I don't put anything here, then it means I am saying that all the elements that are separated by a space should be entered into a list that is S. So basically this list S will contain all the elements that are separated by spaces. Okay, so I hope you understand the spaces. So there is a very long key space bar, which we simply press that, and that is the space. So now, if we reverse that, if we reverse all of, I mean, if we now our if we say that S is equal to string dot split and parenthesis, so a string, another a list will be generated which will have all the elements as which will have all the, let us say, I'll show you one example. So let us say I'm going to call a string as okay, we are good, and we will simply say maybe string dot split, and we are saying that it should be splitted by spaces. Then it will return me a list that will have elements as the string that are separated by those spaces. Okay, so this we are doing, and then we are saying that okay, it should be rearranged in a reversed manner. So it says that okay, last index first to first index, and it should be stepped by -1. So then we join all of them, and we'll get our desired string. Okay, so let us say we run this, and what we'll do, we'll check if we are getting desired thing as we are expecting. So we'll say rev string underscore one, sorry, ref string underscore one, and then we are supplying it a string, and we'll try to see what it returns. Okay, so basically this should be, actually this is a problem. I was using word here, sorry, a PowerPoint here, and when we there can be a possibility that the way strings are words are rendered in the word, or the way they are rendered in a text editor, that is different. So that is why this error had come. So maybe in your course you are told that you should be careful using your text editors, not as Office or maybe other kind of things. So we can see that our string has been reversed, as we have tutorial for our course every Friday when you are reading from right to left. Okay. So similarly, in next case, we want this kind of behavior, that the position of the word remains same, but the letters within the word are reversed. So what would we do is, uh, okay, so what this is our second function. So it will also take input as a string, and then we will split the string, but we will not reverse it. Mind you, we are splitting the string, but we are not reversing it. If we reverse it here, then again what we will get? We will get the position of our words to be reversed, but we don't want that. So that is why we have not done any reversal here, and we have defined a list. Just we have defined a different list, it's an empty list. So then what we are going to do is, we are going to choose every element in the list. We are going to choose every element in the list S that we have just created, and we are going to reverse it. We are going to reverse the element. So if it is WEV, it will reverse as EW, and it will append to L. So this is how we will get a list L that will have that will have that will have the words that has its letters to be reversed, and it will be stored like that. And then what we'll do, we'll again use an inbuilt function that says, okay, join all those and return as a string. Okay, so you can also try this function dot join. Okay, so dot join is taking basically input as a list, so you need to be careful about that. So we are running this, and if we want to check here, so I am for now I am just using this. I mean, I have just told you about the first function and the second function, and this third reversal is actually I'm leaving up to you. You should try it. It's not very difficult now, because you know how to reverse the position of the words and how to reverse the position of the letters. So I will leave this up to you, and we'll try to look for this. So we'll run this, and it won't the input as a string, so we'll supply it string as an input. So you can see it has given us this. One thing, yeah, we need to be careful. I had supplied this for a string I had supplied this um, uh, the double quote for the string. That is not required, because input is already converted to the string. So if I remove this, we'll get the correct answer that we are expecting. But anyways, you must have got the point. So if I enter this, we'll get what we actually were expecting. Okay. So I want you guys to try the third case. You'll be getting this presentation, and you'll be getting the video and everything. You guys should try it on your own. Okay. So now we'll be moving to third problem. So in this problem, what we want to do, we let's say we have a list, and we want to remove any empty sequence that is in the list. So let us say I have a list. For example, I'm making a list here. So let us say I have a list 4 comma 8 comma maybe comma, and we have a empty string, and we have an empty list. So these are the example of sequences: the string, list, tuple. These are the example of sequences. So let us say I have this kind of list. So when I process this list, I should get an output as, it should look like 4 comma 8 comma Q Y G G, and it should omit all the sequences that are that are empty. So how would we proceed that? So what we would like to do, as always, first we'll check whether our input is correct or not. If our input is correct, then we'll move on. Then for for our input, we will see that each element will check the type of each element in our input. So if the type is integer, we don't bother about that, because the integer type does not have length. Okay, and it's not also empty. Okay, so what empty sequence can look like? So integer is not a sequence, float is not a sequence, complex number is not a sequence. So we'll not be checking about that, we'll be checking about only the sequences. So if it is a list, if it is a string, if it is a if it is a tuple, then only we will check. And when I'm saying that if we look at this line, I'm saying if element in the list is a sequence, we check its length. Why we are checking the length? Because if length is 0, means the particular sequence is empty. So if length is 0, we'll remove it from the list, and then we will move on. Okay, so this is our third problem. So this is a simple function. It will take input as a list, so I'm calling it remove empty sequence, because we that's the motive of this function. So we'll check for the input. If input is not a list, then we'll return with a proper warning. But if our input is a list, then we will say that, okay, for I in the list, we will check if type of I is list, or type of I is string, or type of I is tuple. If that is true, then we will check the length of I. And if length of I is 0, then we will remove that particular element, and then we'll return our list. Okay. So it's a very simple program, but it's a very handy program. It can be very useful at times when you have a long list, and you have some empty entries and you don't want them to be there. Then in that case, it is going to be very handy at times. So if we run this program, and below is a list that that has first element as an empty string, then second element is a integer, float, then a string which is not empty, then a complex number, then we have an empty tuple. Okay, so this way we have some empty entries, empty sequences in our string. We will check for them, and we will remove them, we will omit them, and this is how we will get the entries which are not invalid. So invalid entries are basically the empty sequences. If you have any doubt, you can simply check the uh, length of, let us say it's an empty string. So if we see the length is 0, similarly if we do, this is an empty string, length is 0, and you can check the type as well, length is 0. So this is if we use those inbuilt functions properly, they can be very handy at times. You can do uh, even the heavy applications mostly are based upon these inbuilt functions only. They are developed with the help of these inbuilt functions, so they can be very handy. So it will be really useful if you go back and try all those things, and try to get acquainted with the with all those functions and methods. So it will really be useful, and all those type of problems, it will be it will be very helpful to you, as you grow in your career. So these are small problems, but these can be really helpful maybe in your big projects. Okay, so this is